Hey there, kiddos. We're going to talk real quickly about something called direct variation, which you have done and seen before because you have dealt with rate of change, also known as slope. You've also dealt with proportions. They're all direct variation kind of problems because a proportion is nothing more than a type of direct variation. But here is your definition. Direct variation is a linear relationship between two variables in this case, we're going to call them x and y. That can be written in the form, sorry I had to squish this up. It can be written like this. It can always be written in the form y equals kx, where k is what we call the constant of proportionality. And you're going to get asked about k a lot today. They're going to ask you to find the constant of proportionality. All it is the rate of change. It's just the slope of whatever it is you're dealing with. But it's the constant of proportionality, and it cannot be zero. K cannot equal zero. It has to be a non-zero constant. So the first thing we're going to do is just decide if what we're looking at is an example of direct variation. If it is, we're going to identify what k is. Remember, it has to be in this form, y equals kx. If it can be written in that form, then we're all good. Okay, so look at number one. It says y equals 4x. Well, I think that looks a lot like y equals kx, except in place of the k, I put a 4. So yes, this is a direct variation, and k equals 4, because instead of a k, I wrote a 4. Now look at number 2. Number 2 does not look like y equals kx. It says 2x plus y equals 10. Well, in order for me to even determine if it really does look like that, I need y by itself. So I'm going to get y by itself by subtracting 2x on both sides. So now I have y equals, and I'm going to put the negative 2x first. So I have negative 2x plus 10. Well, now if I compare this, negative 2x plus 10, to kx, they don't look anything the same because this doesn't say kx plus a number, it just says kx. This plus 10 makes this not a direct variation because it has something added. This equation has nothing added, so no, that is not a direct variation. Now number 3. Same kind of problem. My x and y are all together on the same side. I've got to get y by itself, so that's the first thing I'm going to do. I'm going to add 3x to both sides, so I get 5y equals 3x. Because when I add 0 plus 3x, it's just 3x. And then I'm going to divide both sides by 5. And so I have y equals 3 over 5x. Now, does this look like y equals kx? I think it does, except in place of k, I put a 3/5. So yes, this is a direct variation. K equals 3/5. Woot! Okay, so the thing that you need to know, the big important thing, is that as long as it is y equals a coefficient times x, you're good. If you have y equals a coefficient times x plus or minus something, then it can't be a direct variation. It has to be just a number times x. So let's do some examples. Number 4 says y varies directly with x. That's really important. That means it's going to be a direct variation. There is another type of variation we will learn like in April called inverse variation, and it works different. But so if as long as it says directly, everything we do today will work. So y varies directly with x, and y is 84 when x is 16. We got to find the constant of variation. Well, that means I get to go to this formula, y equals kx. Well, I know that y is 84. And I know that x is 16. So I have y equals k times x. Well, I want to get k by itself because that's what I'm trying to find. So I'm going to divide both sides by 16. And so I'm going to pull out my handy dandy calculator. And I get that k equals 5.25. Now you can either write it as a decimal, 5.25, or you can turn it into a fraction and say that k is 21 over 4. They're both acceptable. I don't care which one you choose. The only reason I would not want you to write a decimal is if that was a repeating decimal, but it doesn't, so we're good. Now, part B says to write a direct variation equation to represent this situation. Super easy. I go back. I've got to have y equals kx. This time I don't care what y and x are. I just know that k is 5.25. So my direct variation equation is y equals 5.25x. I just plug in what I got for k into the problem. So now number 5, the amount of chlorine needed for a swimming pool varies directly with the amount of water needed to fill the pool. If 16 units of chlorine are needed for every 1,250 gallons of water, write an equation to represent this situation. It's just like number 4, part A. First thing I'm going to have to do is find out what K equals. So the amount of chlorine, C, that's going to be our Y, varies directly with the amount of water, W, which is going to be our X, because Y varies directly with X. So now we know that C is Y and W is X, and all those letters just got real confusing real fast. But if I know I need 16 units of chlorine, that's my Y. I want to find K, and I know that my X is 1250. Then to find K, I'm going to divide by 1250 on both sides, and it's going to give me a funky, weird, small number. I get that K is equal to 0.0128. That's what the decimal comes out to be. Yes, it is small. Because what that means, what this little K tells me, is that I need this much chlorine for this many units of chlorine for 1 gallon of water. Not a whole bunch. Okay? You don't need a lot. But that's not what they asked for. What they asked for was the equation. So now I got to go back and write my equation. Y equals 0.0128 times X. The reason this is important, man, if you have a swimming pool and you need to know how much chlorine goes in your water, you don't want to screw it up. If you have ever swam in a swimming pool with not enough or too much chlorine, it's not a fun pool to swim in. See? Right there. Great use of algebra in the real world. All right, so number 6. If y is directly proportional, y'all, that's the same thing as saying varies directly. It means the same thing. To x, and y is 8 when x is 10. What's the value of y when x is 5? Hey, look, it's a proportion. Y is 8 when x is 10. What is y when x is 5? I can just cross multiply. 8 times 5 is 40. 10 times y is 10y. And when I divide both sides by 10, I get that y equals 4. Just set up a proportion and solve. They give you 3 pieces to the puzzle. Yay. Number 7, you've done this. It says, look at the table below. If y varies directly with x, what's the constant of variation? They're asking you to find the rate of change. They want the slope. So you're just going to use the table and find your change in y over your change in x. Okay? You can also do what we've been doing and plug it into the y equals kx problem in math problem and find out what k equals, but all they're really asking for is the rate of change or the slope. So the change in the y values from 216 to 270 is 50, adding 54. And your change in x from 12 to 15 is adding 3. So k is going to be 54 over 3. And if I do that math, I get that k equals 18. So my constant of variation is 18. And that's all they ask for. They don't ask for the equation this time. They just said what's the constant of variation, which is the slope, which is nothing more than rate of change, something you've been doing for a week now. So it should be pretty, hopefully it's stuck in your brain. If not, there's another practice. So that is direct variation. We're going to practice this when you come to class tomorrow, and I will see you then.